Hello, hi all. I want to welcome you to today's lecture. Today we'll be talking about measurement. We're going to see how important measurement is to chemistry. And of course, I won't be wrong to say that the importance of measurement in what air is to us is what measurement is to chemistry. That will be a very correct statement. Okay, let's take it off immediately. As usual, first, we're going to start with a nice quote. This quote is from Professor Chinua Achebe. Professor Chinua Achebe was a Nigerian-born American professor of literature and English. This is a very popular quote from where I came from. It says, "Procrastination is a lazy man's apology." I'm not going to talk much about it, but it's something you can always think over. Now, let's look at what do we intend to achieve in this class today. Number one, the first thing we want to achieve, of course, are the learning objectives, or you can call it the learning goals. Number one, we need to recognize both the American and the metric system of measurements, and then how to convert from one of them to another. We're going to know how we convert from one metric system to English system, and from English system to metric system. We're going to see how that works. Or if you don't want to call it English system, the old English system is also called American system of measurement. And then we're going to be using the factor unit method, which is, other people, it can also be called the dimensional analysis. Dimensional analysis, the factor unit method, or the dimensional analysis. Dimensional analysis, that's the name. In solving conversion and dosage problems. We're going to see this a lot. Particularly dosage problems is important for people in this class because you deal with a lot of dosages by the time most of you get into your majors in health professionals. Okay, let's take it out immediately. Let's just start immediately without wasting time. Measurement. Now, for a measurement to be valid, every measurement must consist of two things. One, a measurement must have a number. A measurement must have a number and a numerical value. It has to have these two things for that measurement to be valid. And then, okay, like I said, it needs to have a number or a numerical value and then an identifying unit. Now, if a number doesn't have a unit, if it doesn't make any sense if a measurement. Okay, assuming I just said 2, is it 2 gallons or 2 granules or 2 cars or $2 or 2 naira? It can be 2 anything. But the moment I say 2 gallons, I've actually communicated the meaning of that 2. So like I usually take my students, no number, no value should be left naked. No number should be left alone. Every number must have a unit. Must have a unit. For you to make a better communication, units are indispensable. Now, another example we have here is 25 degrees Celsius is telling you about temperature in degrees Celsius, 212 degrees Fahrenheit. So it is, again, based on agreed, or sometimes they could be arbitrary, but the most important thing is that people come together, agree in those measurements, and they want to use them to actually make some defining factors. They want to use it to ascribe to things, and that is why it is a very big tool of communication. So if you look at this now, this is a pint of blood. So you can easily say a pint of blood. This is a pint of blood. If someone is going to get a transfusion, this is a pint of blood. Is how we can measure blood, particularly when you are transfusing it. Now, if you look at these bottles contain different sodas in different, one of the commonest ones they use here is the 35 milliliter soda cans. So you need to, if I just said 35, that wouldn't have made any meaning. But I need to say, okay, I need a 35 ml or 25 ml or 10 ml soda can. And that is when that communication is reasonable. If I go to a grocer and say, okay, I need that, the person is going to understand me. So like I tell my students, measurement is an indispensable tool of communication, and it is important we see it that way. So what are the systems of measurement we're going to be talking about? The systems of measurement here we're going to be talking about. There are two main systems of measurement. The first one and the most universal is the metric system of measurement. The metric system of measurement uses larger and smaller units that are related by factors of 10. We're going to see what that means much later. And those factors of 10 make us to handle some very large or very big numbers into manageable, smaller numbers that are not very bulky. Of course, it is widely used in other parts of the world except the United States. Now, on the other hand, the English system is primarily used by the United States, so it's also called the American system of measurement. It's also called the American system because it's the old English system. Now, the metric system itself uses four basic units we'll be talking about. So these basic units in metric system are units that are foundational measurements that others are derived from. So there are specific units from which other units are obtained either by multiplication or division. These guys are foundational, so you have to use them for. Okay, give me an example. Now we have the meters. Meter is a unit of measuring length. Grams measures mass. Liters measures volume, and seconds measures time. Now, of course, if I combine meters on top and seconds below, it gives meters per second. And meters per second is actually the unit of speed, S. So what it means is that these basic units are from where we derive every other unit we're going to be coming across. And it's important. So there are a little bit of more than this one, but with the scope of our study, with the scope of this class, we're going to be only talking about these four basic units of measurements. And then let's take it to the next slide. So metric prefixes. Metric prefixes are those unique one-letter symbols. Those letter symbols signifies multiples of a base unit. And what they actually do is that they increase the base unit or decrease it by either a factor of this or by a factor of this. So if you multiply by a factor of this, 10 raised to the power x, it will increase by this factor. If you multiply by this, so this will decrease it, and this will increase it. A good example now, if we say 1 kilogram, remember earlier, gram is the basic unit of mass. Look at it here. Gram is the basic unit of mass. Now, if we say 1 kilogram, what it means is that it simply means kilo means 1,000. So it means 1,000 times gram. That's exactly what it means. So if you look at it here, it just simply means kilo means 1,000, which is 10 raised to the power 3 times the gram. So what it means is that with respect to this gram, 1 kilogram, if you remove the kilo at a student, the best way to figure it out is that remove this and replace it by the numerical figure. If you replace kilo by the numerical figure for 10 raised to the power 3 is this, or this times the basic unit. So if you times that by this, so if you replace it by this, it becomes 1,000 grams. So at any point in time, a kilogram, replacing it by this simply means 10 raised to the power 3 of gram. And this, of course, is a very good source of a conversion factor, as we're going to do it. So you need to remember, it is your responsibility to memorize these metric prefixes. Particularly, it is your duty to memorize from mega to nano. I'm going to skip the pico for your class, but it's your responsibility to measure this. Mega means 1 million, 1 times 10 to the power of 6. Kilo, 10 to the power of 3. Deci, 10 to negative 1. Centi, 10 to negative 2. Milli, 10 to negative 3. Micro, 10 to negative 6. And nano, 10 to the negative 9. And we're going to use this to solve some problems and see their direct applications as we move on in this class. So now, common English and metric system and their various relationships. Of course, for us to understand measurement as it is, every measurement should be convertible, easily convertible from one unit to another. So no matter what system it is, if you can easily convert it and interpret it, you're going to use it for whatever, either calculation or whatever thread you want to use it for. So let's look at this. 1 inch is equal to 2.54 cm. These are all the conversion units between English units and the metric system. We have that of mass here. 1 1 oz is 28.35 grams, 1 pound is 453.6 grams, 1 kilogram is 2.25 pounds. And again, we have the volume on this side. Now, I usually give this in exam most times in the first exam. And I ask students to always have this table and use it to work with. Most of the questions I'm going to give you will hover around most of these problems. Now, unit conversions. The basic idea of unit conversions we're going to be dealing with is using what we call the factor unit method. The factor unit method is also called dimensional analysis. In dimensional analysis, we're going to be using the concept of cancelling the undesired units and getting the desired ones. And what are we simply going to do? We make some assumptions. Now, I'm not going to be reading these steps because the moment I teach you, you're going to be seeing the step play out. But I'm going to just talk about the next slide, which is important. Now, for a conversion factor or for dimensional analysis to work, you must have to understand that the relationship between various factors. Now, there are sources of factors. Sources of factors at times can be very clear. At times, it may not be very clear. Now, but you have to really watch very well. Now, sources of factors can be defined relationships that are very clear. Defined relationships that you can say, okay, in every 1 meter, there is 1 centimeter. Of course, this makes sense because remember again, centimeter is a metric prefix. So centi simply means, as if we put 1 here, 1 centimeter, of course, it's going to give us centi means 10 to the negative 2 meters. Of course, when you turn this upside down again, you multiply both of them by 100. That's how you get this. So 1 meter gives you 100 centimeter. If you have this, there's an assumption in dimensional analysis that when you divide 1 by anything, it still gives you the same thing, which is correct. So we can change this thing in 2 forms. It can either be 1 meter divided by 100 centimeter, or it can be 100 centimeter divided by 1 meter. It's going to always give you the same thing. It doesn't matter. Any one of them will give you exactly the same thing. 1 meter of this is exactly the same thing. Now, since this is our factor label, we call it a factor unit. You use it to multiply whatever value you are given to get the desired unit you are looking for. Cancel out what you don't need and keep what you need. That is the message of dimensional analysis. It can also come from word problems, like particularly in dosage problems where you have something like this. It says 25 milligram per kilogram body weight. Simply means 25 milligram is equivalent to 1 kilogram body weight. So if this is our equivalent unit, we can say 25 milligram over 1 kilogram or 1 kilogram over 25 milligram. This becomes source of factor unit label or a factor label for us to solve our problems. So the first few problems I'm going to solve, I'm going to try to write the 2 choices of factor label. But at a point, I'm going to stop writing it. I will believe that you're going to be competent in doing that by practice. So let's start with this first problem. In this first problem, it says express 497 grams. Express 497 grams in kilogram and in milligram. So this is 2 questions. So we call this, we're going to express it in kilogram 1, 2. So that's what we're going to do. Now we're going to start the problem. The first, so I'm going to label them 1 and 2. So I'm going to start with number 1. The first one, the idea here is that I have my problem in grams. So I want to convert it from grams to kilogram. That's the first step. So what it means is that I need the relationship, which is this is now the source of my factor label between grams and kilograms. That's what I need. Now, if you look at your table, for now, you can look at the table of your metric prefixes. That will help if you look at this table. To look at the relationship between them, that's okay for now. But at some point, you need to memorize it. So if you look at this table, you can get those from here. That the kilogram will be 10 to the power of 3 of the basic unit. If we know that, and then we're going to solve the problem. So now, first thing you want to do is to always write the factor label for that relationship. Don't just assume immediately. So what I'm going to do, I'm going to write the relationship is going to be, I know that this is a metric prefix. All right? This is the basic. So if I say 1 kilogram, kilo means 10 to the power of 3. It's going to be, if I remove K and put what it means 10 to the power of 3 and I put gram. So 1 kilogram is 10 raised to the power 3 grams. Or you can say 1,000. 10 raised to the power 3 means 1,000. That's exactly what it means. So what are the conversion factors I have now? I have 2 factors now. I'm going to generate 2 factor labels. From this problem now, 2 factor labels. I can easily do a kilogram divided by 10 raised to the power 3. Or I can do, remember this 10 raised to the power 3 grams, or I can do 10 raised to the power 3 grams divided by 1 kilogram. Now, what will decide the one I'm going to use will be what I'm giving. Now, I'm giving grams, right? And I want to do it in kilogram. What it means is that I'll need to cancel my grams. If I'm going to cancel my grams, I'm going to put it on the bottom to it cancel. And if that was what I'm going to do, then let's do it. So what it means is that, again, start from the known. You are given 497 grams. Now, I'm going to use a diagonal. If you want to cancel gram, it's going to be diagonally down. So if you look at this relationship, which one do you have grams down? It is this one. So that's what I'm going to use. So I'm going to take this and put it 10 to the power of 3 grams, 1 kilogram. Again, let's see if that cancels. Gram cancels grams. That canceled well. And if you multiply, if you divide 497 divided by this, that's going to give you 0.497 kilogram. Now, ensure that what you don't want always cancels. That is the first thing you need to do. Make sure that what you don't need is on the bottom and it cancels. And if what you have is on top, just know that that checks you and your answer is correct. Now, for the second one, let's see. In milligrams, it says the same thing. We're going to check it to milligrams. Now, there are 2 ways you can do this. You can say, okay, if I have it here already, I can take it directly. But I always tell students, do it from the basic unit. Again, let's start from what we have. So here we're going from grams to milligrams. That's what the question is. Milli simply means a 10 to negative 3. So what will be the relationship between these two? The relationship is going to be 1 milligram. Of course, milli means 10 to the power of 3. So I'm going to replace that 10 to the power negative 3 grams. So that's what it is. So 1 milligram is 10 to the negative 3, 10 raised to the power to the negative 3 grams. And again, what do I have? I can make 2 factors. Okay, I'm going to write the factors here. What are the 2 factors? I can have 1 milligram over 10 to the power of negative 3. Or I can have 10 to the negative 3 grams over 1 milligram. However, again, I want my grams to cancel. So my grams is going to be down. I'm still going to use this one. So I'm going to start 497 grams. I'm going to have 1 milligram, 10 to the power of negative 3 grams. Let's see if that cancels. If it cancels, we are right. It cancels well. And what it means, our answer is going to be, when you divide this, you're going to get 497,000 milligrams. This is what you get. So this is exactly what we call the factor unit method of dimensional analysis. This is what we mean by dimensional analysis. That's exactly what we use in solving this problem. So let's now solve. Now let's go to number 2. It says, calculate the number of yards in 371 kilogram. Again, now, this is from the yard is the American system. Want to know what it is in the metric system. So that's what you're going to know. What is the conversion factor? Again, you can always go back and look at those conversion. Look at the table I gave you. You can go here. Let's see if we can have it here. Or if you have 2 yard. Do we have it here? Okay, I don't have the direct conversion here, but that is not a problem. We can always make it instead of making it 2-step conversion for now. I'm not going to do that for you. We're just starting. I'm going to use the direct conversion. I have it here in my book. I have it here usually in my head. So, but anytime, remember, you're not going to be any direct conversion between English to metric or metric to English. You're going to be given that. The only thing you are required to memorize in this class is just the metric prefixes. Okay, let's see what's the unit. Of course, 1 mile. I'm going to use my red. I want to write with the red. 1 mile is equivalent to 1 meter is equivalent to 1.094 yards. This is the relationship between these two. Again, I can set up two conversion factors. I can say 1 meter over 1.094 yards. Or I can say 1.094 yards divided by 1 meter. So now, I'll say this is what I have. So my question here is, I'm going from, say calculate the number of yards. So I want to go from meters to yards. That's the question. That's what I want to do. So let's start. So I have my, always what you're given, you're going to write it first. And then you're going to multiply it with your unit. Now, I want to remove meters. My meters are going to be on bottom. So the one that meter is on bottom is this one. So this is what I'm going to use. I'm going to use this one here. So what it means, I'm going to say 1 meter here, 1.094 yards. Again, if we cancel, you see, meters cancel meters. And my answer is, if we multiply this, it will give you 406 yards. And that becomes your answer. Now, you can always pause this video and then go and practice problems, come back and check it for comprehension. It's really important you do that. So you can pause this, you can just pause this, try it yourself and come back. However, in this one, I'm going to be introducing how we can now solve problems involving more than one unit. Now, the same thing is involved. The same thing is involved. What do? In this case, instead of having just one factor, you're going to be having two factors that you manipulate. So what are you going to do? This involves two units. So you're just going to cancel out the undesired ones and just get the desired ones by manipulating and knowing where to place your undesired value and make sure it cancels. Okay, so it says speed limit, area speed limit is 350 kilometers per second. It says how fast can you go with your personal jet in miles per hour? So we want to convert from kilometers question, say kilometers per second to miles per hour. That is what we want to do. So the first, now, what are the conversion units we have? We have 1 mile is equal to this, and have 1 hour is equal to 3600 seconds. So again, I'm not going to write these two conversion factors, but I'm going to show you, we're going to start and do the problem now. I believe that at this point, you're competent in writing just the conversion factors. So we have now, I tell students, when you see kilometer per second, this means divide. Just write it as a proper division. It helps. Now I'm going to multiply this by the next one. Now I want it to be in kilometer per second. Let's work with the length first, the kilometer, the miles and kilometer. It is in kilometer and I want it to be, it's in kilometer. I want it to be in miles. What it means, my miles is going to be on top. So I'm going to put my miles on top, and then my kilometer is going to be on the bottom. Kilometer. I'm going to cancel immediately. Now, if you look at the kilometer cancels kilometer immediately. I'm going to go back to my red. Now, so I have my miles on top now, which is good. I need to deal with seconds. To deal with seconds, we're going to be dealing with this one. If you look at that. Now, my seconds is down here. I want to take away the seconds. What it means is that I have to take the seconds up to cancel it. So what it means is that, and that makes sense because the hour is going to be on the bottom. So I'm going to have my 1 hour here because I don't want to cancel it. I want to cancel seconds. That is 600 seconds. Let's see what happens again. If you look at this, seconds, we cancel seconds. And when you multiply all you have your answer miles over hour. So you have it in miles and you have it in hour. And that is very correct. So we're going to get 7.8 times 10 to the power of 5 miles per hour. So that is how you solve problems that have more than one conversion units. It can be 3, it can be 4, it can be as many as possible. So what matters in any case is for you to know how to do the problems and put them together. Now, it says convert the following to another example. This also involves the metric system. So in this case, of course, remember micro. I'm not going to show you this thing again, but if you can remember always when you want to get this conversion factor involving a prefix, start with that one first. So I'm going to just say 1 micrometer. Meter is the basic unit. Micro means 10 to the power 6. So it's going to be equal to, I'll remove this and replace it by 10 to the power of 6. So it's going to be 10 to the power of 6 meters. So this becomes my conversion factor. If this is my conversion factor now, I'm going to write what I have. What am I given? I was given 13.02 meters. If I draw this my table, of course this is over 1 because there's nothing given. Then I want it to go to this. Now, if I want it to be in this, that means this has to be on top. What it means is that my meters have to be down. So it's going to be 1 micrometer, 10 to the negative 6 meters. Let's see what happens here. Meters cancel meters. And when you divide this, it's going to give you 1.302 times 10 to the 7 micrometers. Again, I don't need meter. Meter is gone. What I only left is my micrometer is on top of the division sign, and that is what you want. Now again, this one again is going from grams to kilogram like the one we did earlier too. Again, 1 kilogram will be 10 to the 3 grams. So I'm going to do it 4.91 times 10 to the 6 grams. That's what I'm giving. Now, I want to take away my grams. My grams is going to be down here. And then my kilogram is going to be on top. And then again, if I cancel and cancel, multiply, this is going to give me 4910 kilograms. Now, you can pause a little bit, try out this a few while, and then come back to it. You can just try it a few while, and then come back to it. This again involves more than one conversion factor. In fact, at times in exam, I'm only going to give you a few things, and so okay, use it to do the conversion factor. Okay, let me give you a few things here. So let me complete this question. So assuming I gave you 1 liter is equivalent to 1,000 mils, and I also give you 1 quart is equal to 0.946 liters. Now this is what they are. So pause this video, try out these problems, and then come back and check if you got it right. Okay, I go immediately and do the problem. So how do we do it? Now it says convert using fact from, we're going to go from converting from mils. That's what the problem says, to quart. If you look at this, we don't have mil to quart directly. It is not given to us completely, directly. Now, since it's not given to us, you have to do some thinking in a snapshot. What is the thinking? Oh, I can make it into 3. But first, I can go from mils to liters. If I have it in liters, then I can convert it to quart. So what we're going to do here is that we're going to convert from mils to liters, liters to quart. So it's going to involve a 3-step conversion. And now what do you need to know? For each of them, you need to know the relationship. This is the relationship between these two. This is the relationship I'm going to use for the first part. The second part, I'm going to use this. So let's start. What are we given? I have 2.06 times 10 to the negative 4 mils. That's where I start. Now first, I want to convert it to liters first. Because if I get it in liters, I cannot get to quarts. That is my desired value. What relationship? 1 liter is equal to this. Now I want to take away mils. What it means is that my mils is going to be under. So it's going to be 1,000 mils here, 1 liter up. So that's going to be mils, we cancel mils. And then I'm going to have this. Now I have it in liters. And now if I have it in liters, I can easily get it to quart using this direct conversion. So now since I want it in quart, my quart has to be on top. So I'm going to say my quart is going to be 1 quart has to be on top. And then 0.946 liters has to be on bottom. Let's see if that is correct by cancelling. Liter cancels liters. And at the end of the day, I have everything in quart. And if you do your multiplication very well, your answer will be 2.18 times 10 to the negative 7 quarts. So the same thing goes in here. In this one now, if you look at what I gave you here, you can easily use this table to do that if you don't have the direct conversion from kilometer to inch. So if you look at, you can easily convert from kilometer to meters using metric prefixes. You can convert from meters to centimeter using metric prefixes. But from centimeter to inch, you have that here. So you're going to think quickly. This is a 4-step conversion process. Let's see how that goes. 4-step conversion process. So what I'm going to do now is that now kilometer, I can easily take it to the base unit. I can easily do from kilometers to meters using metric prefixes. I know the kilo just means 1,000. I can convert from meter to centimeter. Again, using metric prefixes, because centi means 10 to the negative 2. And again, I can now go from centimeter to inch, because that's the common one I have. In this kind of problem, the one I know here will be given to you will be 1 inch. You don't need to memorize this. 2.54 centimeter. So this is what you'll be given. You don't have to think. So let's move. Now, if you see this kind of problem, it's always good to first of all convert it to the basic unit. If you have everything to the basic unit, you can also take it away from the basic unit. That helps you to navigate the long chain of conversion. Let's start. So we're going to say 5.78 kilometer. Now, if I want to convert kilometer to meters, always write out your conversion factor. Remember that. Okay, I can just write it around here. Remember that there is always a kilometer will be 10 raised to power 3 meters. So if I use this I want to remove my kilometer, what it means is that my kilometer is going to be on the bottom. My 10 raised to power 3 meters is going to be here. And I cancel that. First of all, it is gone. If that is gone, I continue the second step. In the second step, I have it in meters now because kilometer is gone. I want to convert it to centimeter. Again, remember, 1 centimeter. 1 centimeter. Centimeter simply means 10 to the negative 2 of the basic unit. So it's going to be 10. So if this is what I'm going to have the second one, what do? I'm converting from meters to centimeter. That means I want to remove these meters. This meters has to be on the bottom. 10 raised to power negative 2 meters. And then I'm going to move this thing up. What it means is that my centimeter is going to be on top. So it's going to be 1 centimeter. Again, if I cancel, I like canceling immediately so that is very clear and students don't get confused. Now, one last thing. So I have done this one. I did this one. Now I want to take it from centimeter to inches using this, because this means centimeter means we're going from metric system to English system. Since I want it to be in inches, my inches have to be on top. So what is it going to be? So I'm going to have 1 inch on top, 2.54 centimeter below. Again, if you see, centimeter cancels centimeter, and everything is cancelled, and I have my inches that is desired on top, and that is going to give us 2.28 times 10 to the 5 inches. That is how you solve this problem. So it doesn't matter how long the problem is. What matters is methodical way of always converting from one unit to another. Now, we're now getting to the dosage problems. This is the dosage problems. The solving dosage problems is not different from this one. The only most important thing in dosage problems is that the conversion is given as a word problem. That's the hint. The hint here is that the conversion is given as a word problem. What it means, you have to read it and figure it out. It's a word problem. So you have to read it with the comprehension to understand it. And usually what you need to do is to take a bunch of conversion factors and multiply them together until you get the desired unit you're looking for. So it says a certain infant animal has a concentration of this guy. The dosage indicates that you are given. Now, let's see. This is a conversion factor because it has more than one unit. Just know anything that has more than one unit can be used as a conversion factor. Now, another one, this is another conversion factor. You just note it. He said this indicates that you administer 5 milligrams per kilogram body weight to the patient. If you want to lower a child's body that weighs 23 pounds, how many ml of Tylenol solution should you administer? So you're looking for the ml. So in all these things, we want to manipulate it in such a way that the mls are gone. Usually I tell students, start with the one that is not a conversion factor, the one that is a single unit, and we have that to be 23 pounds. So now, if you look at this, there is kilogram here, there is pounds. So we're going to move this from pounds to kilogram. And remember, if you look at that conversion unit table, if we go back here, you're going to see it that a kilogram is 2.205 pounds. So we're going to use that to do it. So we know that a kilogram is 2.205 pounds. Let's move on. So we're going to start from here. So we have 23.0 pounds. Convert to kilogram first. So I'm going to say 1 kilogram will be 2.205 pounds. And then if I cancel this, you see pounds is gone with pounds. I have it in kilogram. Then I continue. But I'm not done. Remember, I'm looking for males. You say, how many males? This is the question of the terminology is given. Now, what next? I don't need kilogram here. I look for the conversion factor that has a kilogram to eliminate it. 5.0 milligram per kilogram. I'm going to use this. And good enough, kilogram is on the bottom. So if I say 5.0 milligram over 1 kilogram, you see again, kilogram cancels kilogram. But I don't need milligram, of course. How can I move my milligram again? What has milligram? I go back. Something has milligram here. I look at this. What has milligram is this one. And if you look at this one now, if I bring it here, but it says 10 milligram. If I say 10 milligram over 1 mil, I have milligram square. That is wrong. What am I going to do? I will flip it. So I'm going to flip it from 10 milligram over 1 mil. If I flip it, or I can use, this is the work, just like when we did our conversion factor. So what am I going to do? I'm going to take away this. I don't need it. I don't need this. I don't need this. So what I'm going to say 1 mil, because I need it in milliliter. So whatever you need should be on top over 10 milligrams. And good enough, look at what happens here immediately. Very interesting. The milligram cancels the milligram. And if you do all your calculation, everything is left in mils. So this is going to give you 5.2 mils. So the basic thing we did here is that we flipped this last one to get it correctly. You have to flip it because it is equivalent to each other. Remember when we said it earlier in the dimensional analysis? If you flip it, what matters is that which direction will lead to the cancellation of the undesired unit, and then that will make your desired unit to stay stable on its own. So this is how you solve this kind of problem. Let's do a few more dosage problems here. It says, if an IV is mixed so that each 150 mils contains this. Now look at this question. This is a conversion factor. Like I said, it is usually given as a word problem. At times it's there. It's hidden. You need to read it. That's dosage. And remember, most of you going into health sciences, you're going to be doing this a lot. Of lidocaine. It says, how many minutes will it take for you to give 750 milligram load to be administered if the patient receives this another conversion factor? Again, I advise students, start with a single unit. This is the only single unit we have. So I'm going to start with that. So I'm going to say 750 milligram. Well, I'm using a different color this time. It's all right. Now, I have to take away this milligram because I'm looking for, the question says, how many minutes? How many minutes? Okay, let me do this. How many minutes? This is what I'm looking for. So, now, I can remove this milligram if I use this conversion factor here. 150 mil content. This is a conversion factor. So, and it's interesting. It's going to count. If I say 150 mils, oh no, I'm going to use the green since I started using it already. So, this will be 150 mils divided by 500 milligram. Good enough. We don't have to flip it. It cancels easily on its own. We'll get back to that. Now, again, we want to eliminate mils and make sure everything lands in minutes. So again, look at what we're going to use here. If you look at this again, if you just say 5 mils over minute, what happens here? Your mils will be mils times mils will give you square. Again, you have to flip it. So remember, this is what is given, 5 mil over minute. If you put this here, it's going to be squared mils. So you have to flip it to be 1 minute over 5 mils because this is the desired unit we need to use. So we put that in. So it's going to be 1 minute over 5 mil. Again, beautifully, our mils is gone and we have our answers in unit. And when you multiply everything together, it's going to be 45 minutes. So always pause the video. Feel free to try example this problem. This is another good dosage problem. You can try it on your own and then come back and check it for comprehension. Now you see, a doctor orders administration of a drug at 120 milligram per 100 mils at this. So again, look at this. This is a conversion factor hidden there. This is another one hidden there, 400 mils per 24 hours. See, how many drugs will the patient receive every 8 hours? Again, I told you, always start with the 1 unit one. So I'm going to start with the 1 unit. This is 8 hours. So it's going to be 8.0 hours. If I have that. Now, which of them will take away the hours? Look at it here. This one has the hour. So I'm going to take away the hour first. I will eliminate the hour by saying 400 mils over 24 hour. Again, hour cancels hour. Let's see. Hour cancels hour. I have it in mils. Now, but what I'm looking for is say how many milligrams. We're looking for milligrams. Now, the last one we have there is this one. 120 milligrams per 1000. This simply means 120 milligrams over 1000 mil. That's what we have here. That's exactly what I have here. So what are we going to do? Good enough, the mils is on the bottom, so that will cancel easy. So it's 120 milligrams over 1000 mils. And then again, if I cancel mils, cancels mils, and I have everything in milligrams, and when we multiply it, it's going to give me 16 milligrams as my answer. Now, I want you to pause the video and try this last one before we finish it. So, and this is another long one. Now, don't be intimidated by the size of these dosage problems. What matters is that for you to isolate those conversion factors, put them together to get your desired unit. A nurse practitioner orders an isotonic sodium lactate for 50 mils per kilogram body weight. Of course, this is a conversion factor. Another one. It says to be administered intravenously to 139-pound patient. Okay, this is a single unit. I will likely start with that, but let me look at all that. It says the rate of flow is 150 GTTM per minute. This is another conversion factor. And it is said to deliver this again. This is another conversion factor. So, and it says where the unit GTTS stands for drops of liquid. This is actually a health term. GTS means drops of liquid. Now, it says what is the running time in minutes. So we're looking for minute. This is what we're looking for. If I selected what we need. Now, start with the one that has one unit. And that is 139 pounds. So what am I going to do first? I'm going to do 139 pounds. We'll convert it first of all. 139 pounds. I want to convert it to kilogram. Remember again, I wrote that in before. A kilogram is 2.205 pounds. So to convert it to kilogram, I'll put my 1 kilogram, 2.205 pounds. And then if I cancel my pounds, everything is set. Now, I want to remove the kilogram. I'm going to look for one that has a kilogram. If you look at this, this has a kilogram, 50 mils per kilogram. And good enough, kilogram is on the bottom, so it's going to be easy for us to cancel. So it's going to be 50 mils over 1 kilogram. Again, our kilogram is gone. Oh, no, I'm going to change that to my red. And then after that, what else? I want to remove the mils. Which one has the mils? I look at it. Oh, this one has the mils. Look at it. So I can take away mils from here. And mils is on the bottom. Makes it easy. So it's going to be 20 GTTS over 1 mil. That's what this means. So what am I going to do? I'm going to cancel mils again. And then finally, we want to remove GTTS. And the only unit left we've not used, we've used this one. We've used this one. We've used this one. The only one left is for this one. And our minute, see that is on the bottom. If you put it on the bottom, you multiply GTTS times GTTS on top, it's not going to work. So what is going to, remember this is what we have, 150 GTTS divided by minute. If you put this here, it's going to multiply. No, we want it to be the other one. So it's going to be 1 minute over 150 GTTS. So if I use this, so it's going to be 1 minute over 150 GTTS. And then if I cancel it lastly, this, cancel this. Oh, great. I have everything. This is what I'm looking for, and I have it at last. And when I multiply everything, it's going to give you 420 minutes. That is, and at this point, this is the last problem we're going to solve. Like I said, you can always pause this video, come back and watch them many times, take time, take breaks along the way, and always, come back and watch them for comprehension. And remember, with watching this video, and by the time you practice with the worksheet, you're going to get everything clear. And if you do not get anything clear, do not hesitate to get to me through the usual channel. Thank you once again for listening. Bye at this point.